Thank you for joining this lesson. We're going to handle vector 2, whereby we're going to deal with vectors in 3 dimensions and are parallel to one another, and we also calculate the modulus of a vector. Remember to subscribe to this channel and to also share the link with your friends. Given that vectors PQ equals to 2, 3, 5 and vector RS equals to 6, A minus 1, 15 are parallel, find the value of A, hence calculate the size of vector RS. We should know that when vectors are said to be parallel, they have a scalar multiplier, or rather, one is a scalar multiple of the other. Therefore, if we let, for example, if we just let RS to be a certain value, let's say the scalar multiple we are using is K, the vector PQ, then we will say that for us to get RS, we should multiply all the dimensions and all the components in PQ with a scalar, which is K for this matter. Therefore, the vector RS is 6, then we have A minus 1, and we also have 15. This is equal to the scalar multiple K multiplied by PQ, which is 2, 3, and 5. So we can get this scalar multiple such that when we multiply the components of vector PQ, we're getting RS, now that the two vectors are parallel. So now we can conclude that 2K is equal to 6, which means K is equal to 3. We can also confirm this with another component which has already been provided, the Z dimension, whereby we say this is 5. 5K equals to 15, and this can confirm that the scalar multiple, which is multiplying vector PQ to give us RS, is 3. So which means definitely then the y components in these vectors are related using the same scalar multiple. Therefore, K, which is now 3, when we take 3 and we multiply it with the y component of PQ, which is also 3, we're going to get the y component of this vector, which is A minus 1. If it is A minus 1, then it means we can now obtain the value of A, whereby this is going to be 9 equals to A minus 1. And when negative 1 is taken to the other side, then the value of A will be concluded to be 10. Now that we've known the value of A, then now we can rewrite vector RS to be 6. A is 10, so minus 1, we get a 9 at this point. Then we got 15 as a column vector. This is the vector RS re-expressed now that A has been found. Hence, calculate this sample when we are told this one of any vector RS. This one means the size. These are all the possible languages which can be used instead of that sample. The size, the length of the same vector. It also means the modulus. The modulus. So you can be told to obtain the size, the length, the modulus of the given vector, which is commonly called the magnitude. Magnitude of the same vector. Therefore, all the 4 names will mean the same. For us to get the magnitude of vector RS, then we should take the x component squared, the y component squared, and the z component also squared, then we obtain square root after adding all the squares. Therefore, we will need to take 6 squared plus 9 squared plus 15 squared. This is giving us 342. So for us to get the modulus, the size, the length, and the magnitude of this vector, then we just obtain the square root, which is going to be 18.49. These are units. This is the length of the said vector. Thank you for following. Subscribe and share.